Hello everyone, welcome back. Today we're going to be talking about arithmetic operations. So an arithmetic operation are your standard plus, minus, multiply, divide. Java offers other operations as well in the mathematics package, but for now we will focus on the simple ones that you can type on your keyboard. Now you might be thinking that, well, it just seems like that Java is basically a calculator on a computer. Yes, while it can do many basic calculations, there are also advanced things that we can do with Java, which we'll see as we learn more about Java. Arithmetic operations in Java have some rules that need to be followed. Depending on what variable you use, the operation will behave differently. So let's start off. With integers. If you have a variable, let's say int num, and then we say num equals 2 plus 3, and then we print out the num, we should see 5 on the screen. So addition, you just add it up like regular 2 plus 3. Same with subtraction, regular subtraction. So let's run this. We'll get 5, and we get 5. What if we tried to add numbers that were of different types? Like, let's say we have instead of int num, what if we had like int num equals 3, and we had byte num2 equals 5, and then we said int result equals num plus num2. So we can do this because a num is an integer type, and everywhere we use this variable, we can replace that with the value. So what we're doing here is this will get replaced by the 3, and this will get replaced by the 5. And what we want to printf is actually our result. So we have an int here, and we have a byte here, an int and a byte, and we're setting that to an int variable. What do you think is going to happen? Well, let's run it and see. And we get 8. Now, the reason we are able to do this is because byte has a shorter range than an int. Remember, an int can be anywhere from -2 billion to 2 billion, while a byte can be anywhere from about -100 to 100. So if we say an int result equals some integer type plus some byte type, because the result is of the integer type, we are able to use things that are smaller than integers. But if we said instead of int result, we said byte result, then we see this red underline, which means it's an error. We see incompatible types, possible lossy conversion from int to byte. Means that you might lose some information. We don't know how big num is before we run it. Like, Java wouldn't know. It's when Java runs, then it realizes that it's a small number. But right now, since Java hasn't run, we can't tell how big num is. We just know that num is an integer, and a byte is much, much smaller than an integer. So we cannot do this. So we would have to make this an int, or we could even make this a long. And if we do a long result, then we should see an 8 as well. So we get an 8 as our results down here. In Java, you want to use a bigger data type, a data type that's bigger or the same size as what you're adding up. So right here, since we're adding an int and a byte, we can use a long, we can use an int, we can't use a short or a byte over here. So just keep that in mind. We can even try like minus and see what happens. If we do like 3 minus 5, we should get -2 as our result. And we do get -2 down here as a result. And same with multiplication. If we try multiplication is star. So if we do 3 times 5, we should get 15 as a result. And yes, we get 15. Integer division will do division, but it won't round your result. It'll just cut off your result where it is. So instead of num is equivalent to 3 and num2 equals 5, so let's do num2 divided by num. So then we're doing 5 divided by 3. So if we do 5 divided by 3, the actual result should be 1.6 repeating. But since this is an integer division, we will get just 1 because we don't have decimals in integers. What we should see in result is a 1. We won't see 2 because in integer division, we just cut off the result. So we get a 1. We do not round in integer division. It just becomes whatever the whole number value is for it. So like 5 divided by 3 is like 1.6 repeating. So just cut off the 0.6 repeating and all you get is 1. Now if you do like regular numbers, like if we change this to a 6, 6 divided by 3 is 2. And since there is no decimal point after it, we should just see 2. So there is one more operation that's provided from Java, which is called a modulus operator. Let's change this back to 5. Now when we ran this before, num2 divided by num gave us 1. Let's run this. It gave us 1. We know that the value is 1, but if we want to get our remainder, there's a modulus operator, which is the percent sign. So the percent sign means modulus. And what a modulus does is it tells us what is the remainder after we divide this. So num2 modulus num means we do num2, which is 5. If we divide it by 3 in this case, so 5 divided by 3, what is our remainder going to be? 5 divided by 3 would be 1 remainder 2. We have 1, and then there are 2 left over for 5. So we should get a result of 2. A modulus just tells us what our remainder is, and we get 2 down here as our remainder. So these are most of the arithmetic operations done on integers. Now let's go to floating point. Let's change this to a double. Let's change this to a float. Our result value should be the biggest type, and since double is bigger than a float, we will say double. And let's change these numbers as well. Instead of 3, let's do 3.5. And instead of 5, let's do 5.2f for float. Remember, we need the f for the float. If we say num2 plus num, and we have to change this to %f. If we do this, it'll add like regular. We should get 8.7. And we get 8.7 with a lot of zeros. If you want to make it nice, then you could add the %.1f if you wanted to just limit it to 1 decimal place. And then we would get 8.7. Same thing with minus. It's going to be the same as we did with integers. We'll get 1.7. And multiplication, it's still the same thing. If we run it, we'll get the multiplication of the two numbers, 18.2, rounded to 1 decimal place. Let's see what it would be if we didn't round to 1 decimal place. 1.1999. Now this is interesting. Java will sometimes give us errors in floating point arithmetic because processors are not very accurate when it comes to floating point arithmetic. That's why we get 18.1999. Our actual result of 3.5 times 5.2 will give us 18.2. But sometimes Java does not give the correct answer because processors are not accurate enough to give us the right answer. That's above the scope of this course, but just know that floating point might not always be precise. And let's finish it off with a division. If we divide the numbers, it's going to give us the results the same way as it did for integers. So that's our arithmetic operations for integers and floating point numbers. So let's look at arithmetic operations on something that might be unfamiliar, like strings. So if we have a string word equals hello, and then we have a string result, and we set that equal to word plus word, and then we print out our result %s. What do you think will happen? Well, we have hello here, and when we add strings, we call this concatenation. So what it'll do is it'll take hello and put, for the first word we have hello, and for the second word we have hello. So the result will be hello hello without a space, and both hellos will have a capital H. So when we add strings, we'll get hello hello. We won't have a space, but if we wanted to, we could add a space in here. So then we will get hello space, and then the \n. But we won't see the ending space because it's a space. But if we highlight over it, we will be able to see that there is an extra space here in the result. When we add strings, this is called concatenation. We cannot subtract strings or multiply or divide strings. We can't do those operations. Same with characters. We cannot add, subtract, multiply, or divide characters. So we talked about floating point, integer, and we talked about string arithmetic operations, which is only concatenation. We also cannot modulus a string. And the next video, we will talk about operations on booleans. Now with booleans, we cannot add or subtract them. We cannot do multiplication, division, or modulus of a boolean. Booleans have their own operations. These are called logical operations. And one last thing before we end the video for today is I want to talk about comments. A comment is something that is ignored by Java. So a comment is like writing notes in your program. If you want to write notes in your program, then you would comment. So right here, / means this line. Everything after the / will be ignored by Java. So this is a comment. And if we run this, we should still get hello hello because all we did was added this note or comment in our code. So this is a comment for a single line. If you want to comment for multiple lines, we do / for the beginning of the comment, and you will see that when you hit enter, it will automatically put a * / for the ending of the comment. So anything in here is ignored because we're just putting notes inside our program. So if we run this, we should still see hello hello because these are just notes. You can put a single line comment at the end of a line as well. Hello. you cannot put a single line comment right here, because right here it'll ignore everything after this plus sign over here. Everything after it will be ignored, and since we just have string result equals word plus, it's an incomplete statement, so we cannot do this. But if you do want to add a comment right here, you can add a multiple line comment by doing /* **/*. So this part is ignored. So if you want to comment within a line, but you don't want to mess up the statement that you're writing on the line, then you can use a multiple line comment in a single line. If we run this, we should still see hello, hello, because all we've done is added some notes here, some notes inside our line of code, and some notes here as well. This will be helpful when I'm trying to explain in the next video what Boolean operations are. So we'll end with that.